Now, since this is Acoustics 101 Pro, we will measure our box and compare the results with the modeling software, which is WinISD. So the volume was 32 liters, and in reality it's the same, 32 liters. And let's see the results. So I have two charts over here. I have the frequency response chart. This is the frequency response chart. I have another one with the dampening inside. So as you expect from a sealed box, you have a very linear frequency response, which extends with a nice roll-off till the end of the frequency spectrum around 20 Hertz. And I have another plot over here. Again, I have the two charts stacked onto one another. The green one is with dampening material. But let's compare the blue one with the modeling software. It says the resonant frequency coincides with the peak in the impedance response. So in our case, 39.7 Hertz. And if we go to WinISD, we can see that it's 40.7. So again, it's within the margin of error, 1 Hertz. But if you really want to play with the numbers, it means that the QL is higher. So let's go to 50, and again play with these. As you can see, the resonant frequency is going down, but it's still not there. Let's put a large number, 100, and you can see in this case it says 39.7. So you can interpret that the box has basically no leakage, and if that were be the case, then the modeling results coincide with the measured results. But let's place some dampening material and see how that affects the results. We learned in the first Acoustics 101 course that if you place dampening material inside your box, besides all sorts of benefits, the main idea is the speaker will play like it's in a larger box than it is. So we can see what are the actual results. So after we make the measurement, let's check the frequency response. And so the blue line is the one with the dampening material. So you can see that the response is more flat. The flatness has improved. It's characteristic of a lower Q because it mimics a larger box. So if we go to the impedance chart, we can see that the frequency response, besides that, the fact that the impedance hump is now a bit lower, it's not that spikish, so to say, but the actual frequency has gone down by like 2.7 Hertz. So if we go to WinISD, if you want to replicate this result, although I don't see the point in doing that, if you go here, this is the box, the leakage. The QL stands for box leakage, and QA stands for absorbent material. So if you have absorbent material, you have to reduce this number down to, I don't know, 3. And you can see I don't think this is pretty much accurate. I prefer to leave it at 100 and play with the actual volume. So I'm going to increase the volume of the box to see the perceived volume, so to say. I'm going to increase the volume until I reach the new frequency response of the box. So if I go to 40 liters, you can see now it's 37.9 and we need to reach 37. So let's head back. 45, we're getting close. Let's say that this is the correct volume. So you can see the QTC has gone down from 0.707 to 0.66. And the perceived volume, if we do it in percentage, 46 divided by 32, we have roughly 44% volume increase. But you have to take into consideration that we used a material which is pretty dense. It's pretty dense, and we fill it basically 100%. So there is no exact formula to know your volume gain, because there is different densities, and it very much depends on how much material you place inside the box. So the only way to do it correctly is to have a measurement microphone and measure the exact gain. Actually, in this case, with the measurement microphone, you are only measuring the frequency response. In ported boxes, you can measure the resonant frequency of the box. But if you want to measure the resonant frequency of the box, you will have to measure the impedance. So a microphone won't help you. But anyway, you will need the equipment, which I talk about in Acoustics 201, to actually measure these changes. So the conclusion here is if you fill the box all the way up with dampening material, you will get a considerable gain in enclosure volume.